Hello, my name is Tom Young. I'm a science teacher at Waukesha South High School. And I'm here to tell you a little bit about the ceramics module from Material World's modules at Northwestern University. You know, everything has to be made out of something. And for many of the things in our students' lives, that something is a ceramic material. Now, most of us think about ceramics, cups, saucers, plates, these types of things, or maybe artwork, statuary, or the bathroom, toilets, sinks. But ceramics is so much more in our environment. They fill our everyday lives in places we know and places we don't know. Like, do you know the inside of every electronic device has ceramics? Every integrated circuit is built on a ceramic material. So that means computers, cell phones, CD players, Game Boys, just about anything you have is going to have a ceramic material inside. Space shuttle tiles. Now, most of us don't get a chance to see the space shuttle in person, but it's still there. It's making advances in science, and the tiles that are used are there for heat absorption on re-entry. They're very, very lightweight, but yet they absorb tremendous amounts of heat energy. Closer to home, simple glass is a ceramic material. Whether it's a glass that you use for drinking or for jars, it's still the same. Concrete is technically another type of ceramic material. Concrete in roadways and sidewalks. High tech, you can get ceramics that are different than just the chips, but they're still ceramic materials. And even as simple as the artwork held up on your refrigerator at home is made out of a ceramic type of magnet. So you can see ceramics are all over our students' lives. So it makes sense to put part of that ceramic information into their education. Now, I know what you're saying. I don't have time to put ceramics in. I have trouble getting in what I have to get in now. I understand. I teach in the classroom with the same students that you do, the same time constraints, the same kind of course constraints. And now with national standards being put into all of our educations and standardized testing, true, it becomes, it's like the crunch is even worse than it was before. So maybe as what you see with the ceramics module, try not to look at it as an addition to your curriculum. Take a look at it as maybe a substitution, a way of teaching some of the things you already do now with different props. Now, the ceramics module is composed of six activities. In the first activity, the students compare the ceramic materials to others, like wood and metal and fiber and plastic, for various properties, thermal properties, electrical properties, strength properties, types of things. After they take a look at the properties of what ceramics are compared to other things, then they go out and take a look. What are made out of ceramic materials? Where are they in their environment? And they come in and talk about what they think are made out of ceramics and what things are not. The activity on porosity. Now, porosity is a term most of us don't use and students don't think about, but porosity is simply holes. When we think of solid materials, then and density, then those solid materials, most things, you know, we think of that's just a solid that doesn't have anything to it as far as on its internal structure. Students see that's a piece of copper or that's a piece of glass. But the density of a material, as we normally teach it, usually involves measuring the macroscopic, the length and the width, and using a formula, and with the mass, and we calculate a number, and the students know that the density of copper is so many grams per cubic centimeter, and then they move on. And they'll know it's more than water or less than steel, that kind of thing, but they really don't understand the concept of density. If we think about two materials that are the same chemical structure, gravel and sand, they're just in different forms. Are the densities of these two samples the same? There's a difference between the density of the material and the density of the object. Now, engineers, of which many of your students are going to be engineers in the future, have to worry about the object as well as the material that it's made out of. So therefore, How do you control the density of the object? How dense is this compared to this one? And it comes down to controlling the holes. And as students work through the exercises, things that they once thought of as solid really don't quite look so solid anymore. And in today's world of new materials, a lot is happening at the nanostructure, at the molecular structure. And that's where the holes and how things fit together really come together. The exercise on slip casting, in which they take a powder, like zinc oxide, and take this powder and turn it into something that's hard and usable as a ceramic material. In order to get from one to the other, the process of slip casting, which still dominates the ceramics industry, has to be used. But how do you turn that powder into something that you can pour into a mold? You could add water. And if we add a little water to this powder, and stir it up, we don't really get too much of a powder at all. We get a sticky substance that's much more like peanut butter. Kind of sticks to the spatula and doesn't pour so well. That's never going to pour into a mold. So, reason is that you have these little particles that are charged. Now in chemistry, we talk about polar molecules, talk about van der Waals forces, and the electrostatic nature of these things, and the students shake their heads, and we shake our heads, and we kind of move on to the next thing. And they never really understand or get a feel for what these forces. I never got a feel for what these forces were like until I started trying to slip cast this zinc oxide powder. And it clumps up because these molecules are grabbing onto each other and won't let go. They won't slide past each other, they just grab onto each other. So if we add a little bit of a chemical substance that really is nothing different than a polyelectrolyte, something that gives up electrons or takes electrons. We just add in a few drops, that clumpy, sticky mess now becomes very liquid. In fact, it's a lot like milk and just pours. And you can imagine now I've got something that is pourable into a mold. So I took a powder, turned it into a clumpy mess I couldn't work with, and now into a liquid that can be done. Students are amazed by this. They love it. To take something and change its properties just by adding a few little chemicals is like the old magic sets they may have had when they were a kid. And so we need to bring a little bit of that magic back into this situation. Slip casting is an easy process.